Greetings, everyone. My name is Rasheedat Ekiyoyo, and this semester I had the pleasure of working with my wonderful team on the cooling, housing, and powering of a tabletop electromagnet. This semester, our capstone project was sponsored by the MACS Lab, or the Magneto Active Composites and Structures Laboratory, spearheaded by Dr. Paris von Lockett. In this lab, they're known for creating various soft robotics and flexible devices that are actuating using magnetic fields. So these devices are used for things such as terrestrial locomotion, push and pull tasks, swimming, and more. And you can find them in fields such as biomechanics as well as origami technology, which is used in spacecraft technology. So in this lab, they have various types of magnetic field generators, and one of their most common ones is the tabletop E-core magnet. The tabletop E-core magnet was a magnet developed by a previous capstone group, and it has a steel base, and it weighs about 50 pounds, so it's a fairly heavy magnet. So when this magnet is used for long periods of time, it tends to overheat, and this overheating can reduce the magnetic output, and this is a problem for the lab. So our goal is to create a cooling system that would allow the magnet to be used for longer periods of time, and that is what the MACS Lab tasked us with. They also tasked our team with developing a better wire management system, as well as allowing the tabletop magnet to be maneuvered more conveniently, so being moved from place to place. As well as all of these things, we were also tasked with developing a safety system which would allow people to know whether or not the magnet was too hot to touch and will enable a more safer control of the magnet when used in lab. So our main approaches to doing this, we first decided to do some SketchUps, and we all did some really heavy brainstorming and figuring out like what the general design of the magnet would be. After we figured out a general idea of what the magnet would look like in the housing system, we went to SolidWorks to create a comprehensive CAD model, and we also did comprehensive heat transfer calculations using MATLAB to optimize the process, and we validated these results using SolidWorks computational fluid dynamics add-on. And that is how we were able to get a feel as to how much heat we had to remove from the magnet. So I will go ahead and let the rest of my team carry on this project and talk more about like our design process and all the wonderful things that we were able to accomplish this semester. Thank you so much for your time.